Okay, I'm sure your enjoyment of this lesson will increase exponentially. Oh, I never stop. Okay. So let's see here. Graphing exponential functions. So exponential functions take the form f of x equals a to the x, where x belongs to, what does z represent again?
All integers.
All integers. Okay. Is anybody okay with what group that classifies? Okay, your positive counting numbers, their opposites, and 0. Okay. Where a has got to be positive, and also a can't equal 1. And a big restriction here, a can't be 1 because 1 to any power, regardless if it's positive or negative, is always what? Is always 1. Okay, so that's not going to increase or decrease, so we want something that's going to increase or decrease exponentially very quickly. Oh, that is the homework. Sorry. When I walked over here, I just grabbed the notes and went ahead and pulled them in the folder. Did anybody else need a copy of the notes? Okay. All right. Exponential growth function. So if your base is larger than 1, okay, it's going to grow. So the larger the base, the faster the rate that your function is going to grow. The graph of an exponential function rises from left to right. So let's go ahead and graph 2 to the x and 5 to the x, bless you, on the same grid. So let's go ahead and do a comparison. But there's some characteristics about these that we want to go ahead and make sure we know. For every parent, in this case here, 2 to the x, 5 to the x, what's the y-intercept? It always crosses at what? 1. There you go. Because when we think about it, if we go ahead and start to plug in values, anything to the 0 power will always give me 1. So 2 to the 0, 5 to the 0, they're always going to go ahead and cross at 1. So they have that 1 point in common. But exponentials are also going to have something that I don't believe we've actually seen in here for quite a while. We represent them by the dashed or the dotted lines. Okay, it's going to have a horizontal asymptote. Where does it start for the parents?
It's just the x-axis.
It's just the x-axis. That's absolutely right. So for both of these, even though they have different growth rates, they're both going to have the same horizontal asymptote. Y is equal to 0, the x-axis. Okay, because even if you go ahead and start to throw in negative powers, and let me go ahead and give you one very quickly. Let's say 5 to the x. How about 5 to the negative 2? Does anybody remember how we deal with a negative power? You flip it, so you take the reciprocal. There we go. You take the reciprocal. So if you take the reciprocal of an expression with a negative power, that makes it positive. So this is 1/25. And if you were to continue that, you're going to notice that your denominator with a negative power just continually gets larger and larger and larger. So you got to think, if the denominator becomes infinitely large, what happens to the overall value of the fraction? It gets smaller and smaller, but it will never actually hit what? 0. So mathematically, to us, we're going to go ahead and say it's 0, but mathematically, 0.00000000, it will never hit 0. Okay, it's going to get infinitely close, but it'll never go ahead and touch that. Okay, so whether it's a growth or a decay function, we're always going to start off with the asymptote on the x-axis. In fact, what's the only transformation that can affect the horizontal asymptote? There you go, if it's a vertical shift. Wherever the function goes, that asymptote is going to go right along with it. Okay. Also, another good characteristic, each one of these parents is always going to start at 1, whether it's a growth or a decay, but if you have a scale factor in front of it, okay? Like if I were to change 2 to the x, if I wrote him as 3 times 2 to the x, then his y-intercept would be what? 3. Okay, so in that situation, the y-intercept would be your scale factor up front. But then you also want to be careful, bless you, because if you start moving it horizontally, that's no longer a guarantee. Okay, do you guys remember a lot of the transformations from, say, Algebra 2?
Yeah. Is putting the 3 out front, is that considered a y value transformation or an x value transformation?
That is considered a y transformation. Only, so this would be vertical. Okay, so anything affecting x directly is going to be a horizontal translation or shift. Yeah, so if I were doing that, The same rules are still going to apply. That's actually going to do what horizontally? Stretch it or shrink it? It's going to shrink it. Whenever you multiply x directly, you have to take the reciprocal. That's the true scale factor. So if I actually wanted the graph to double its width, then I would have to put in 1/2. Okay? But the same token, if I wanted to go ahead and shift the graph left or right, if I were to say 2 to the x plus 5, well, we know we're going 5 units, but what direction? Why left? It says plus. There you go. When you add or subtract to x, you always take it the opposite. Remember, the x's were always a lot trickier when it came to the transformations than the y's were. The y's, you always did what you expected to do. Okay. All right, so good. Very good. Okay, well, let's just go ahead and plot a few points. How about we go ahead and do these in some different colors? I'll do 2 to the x in red. Okay, and let's go ahead and create a table here to kind of help us out. So x, 2 to the x. Okay, and let's do a range, maybe just -2 to 2. Okay, my teachers way back in the day just did a nice little span of numbers like that. So now let's plug them in one at a time. So the first one, -2, so 2 to the -2 power.
So be 1 over 1 over 4, right?
1 over 1 over 4?
Wait, just 1 over 4.
1 over 4. There we go. 1/4. There we go. All right. Okay, because every time you have a negative power, you take the reciprocal, it makes it positive. What happens if you take the reciprocal of a positive power? It actually becomes negative. Yeah, all the rules are reversible. Okay. 2 to the -1. 1/2. We already saw anything to the 0 power. 1. 2 to the first. And 2 squared. 4. Okay. So let's see here. We have the 0, 1 that we started at. -1 will give me 1/2. -2 gave me 1/4, and then we got 1 gave me 2, and 2 will give me 4. So let's say, there we go, just like that. Okay, so this is 2 to the x. So I'm going to go ahead and do the other one. Let's choose, say, green. Okay. Okay. 5 to the x. Okay, let's go ahead and do the exact same span. So -2, that's a 2, -1, 0, 1, 2. Okay, so I actually did this one just a moment ago, 5 to the -2. 1/25, okay, which is smaller than the 1/4 we had just a second ago, and I want to bring up that point in just a second. What about 5 to the -1? 1/5. 5 to the 0? Okay, 1. Then 5 to the first, and 5 squared. Okay, so very quickly, see, we are already off our grid. In fact, way off our grid. So 0 will give me 1 as well. Okay, so that's the 1 point they have in common. 1's going to give me 5. Okay, now the others, we're going to have 1/25, and then this other one way down here. So it's going to be like this. And unfortunately, the way I'm drawing it, it looks like I'm going past the asymptote, but I don't mean to. I'm trying to show that the larger the base, you see how he's growing faster? The larger the base, your function is going to grow faster, but just the opposite, it's going to try to get to 0 faster. He's going to have smaller values much faster than, say, 2 to a negative power. Okay, so let's talk about the domain on these. And you'll notice, whether we're looking at 2 or 5, all of these are still going to be the exact same answers. Okay. So can anybody tell me, by show of hands, domain? So basically, how wide is this? Samir, what do you think? It is all reals. Okay. Now, it's definitely easy to see over on the left that we're going to go to -infinity. Okay. Now, these things become very nearly vertical depending on how fast they're going to increase, but there's the key word, nearly. Even though it's almost vertical, they are slowly but surely, okay, stretching their way out there. So they will eventually get to every x value. Okay, so positive infinity. So all reals. Okay. Let's see here. Who haven't I talked to lately? John. What about the range?
1 to infinity.
Now you're close. It definitely will go to infinity. Okay, there's no question about that. But where do we have to start? Do we have any values below 1?
Isn't it 0?
Okay. There you go. Now 0 represents your what? Starts with an A.
Asymptote.
Asymptote. There we go. Now I can go ahead and use that as my starting point so long as I what? There we go. What does the parentheses mean? We're not going to include him. Okay. So he can be my starting point, but we are not going to include him. So that means we can get extraordinarily close. Okay. We already listed the asymptote, so you can put x-axis, or if you're going to give the equation, remember you don't want to put just 0. We want to give the equation for that. Okay, so y equals 0. Intercepts. So the y-intercept is the common for both of them. What's that? I'm actually going to go ahead and draw this up here so I have a little more room. Okay. So the y-intercept is 0, 1. And what about the x-intercept? Okay, there are no x-intercepts yet. No x-intercepts. There we go. Okay, and those are growth functions if your base is larger than 1. All right. So good. That was pretty easy. Well, what do we have here? Now we're talking about a decay function. Where your decay function is going to be if your base is less than 1 but greater than what? Greater than 0. Because remember, one of the restrictions we had was that the base itself cannot be negative. Okay? The base itself can't be negative when we're dealing with an exponential function. So that means we're going to start off relatively large, and very quickly we're going to go ahead and get really small. So what are some similarities that you would see between a growth and a decay? Bless you. Say again, Caroline. Again, go through 0, 1. Okay. What's another one that have the same asymptote? Okay. Same asymptote. All right. So this is going to be y is equal to 0. So we have 1/2 here. Let's go ahead and create a table for him. Let's graph him, and then we can go ahead and do this. This one's definitely decreasing. So here's the x, 1/2 to the x. And let's go ahead and do the same thing. -2, -1, 0, 1, 2. Now here's the thing. I'm taking a fractional value to a negative power. So 1/2 to the -2. So you could go ahead and take the reciprocal of the whole thing. You could say 1 over 1/2 squared. And what is 1/2 squared? Okay, that is 1 over a fourth. And we've seen this multiple times. What happens when you divide by a fraction? You multiply by the reciprocal. But 1 times anything doesn't change, so that's just 4. Okay. So -2 would give me a 4. 1, 2, 3, 4. Okay. Now there's another way that you can go ahead and do this. Typically what I like to do, especially if you have a situation like that, if you have 1/2 or any fraction to a negative power, if you take the reciprocal of just the base, that's enough to change the power on your exponent. So you could just say 2 squared. That also works as well. Okay. You guys remember that from all the exponent rules? Easy, easy. Okay. Good, good, good. So if I were to go ahead and plug in -1, I'm looking for a 1/2 to the -1. So that's just 2. So this one was 4, this one was 2. Just like we were told before, anything to the 0 power is 1. And then to the first would just be, I'm going to go ahead and put a decimal to give myself a little more room, 0.5 and then 0.25. Okay. So let's see here. We have -1, 2, and then we have 1, 1/2, and then a fourth. Okay. There we go. And there's 1/2 to the x. Okay. All right. Creme, what would you say the base is? Base. The domain. Let me rephrase. We know the base is 1/2. It again is all real. Same idea as before. This left side will push out to -infinity. It's going to take a while, but he's going to get there. So -infinity to infinity. Okay. Let's see, the range, Hillary. 0 to infinity. Okay. We know the asymptote is y equals 0. We already went ahead and got that. So let me draw an arrow again. Y-intercept is 0, 1. Okay. No. X-intercept. Okay. And then we already said that it was decreasing. Okay. All right. So there we go. Any questions? Does everyone decay with that? Okay. All right. Next up. Now we're going to start looking at some transformations. I think here we just have vertical, then we have a scalar, then we have a scalar and a reflection. Let's see. So we're coming up with some nice ones here. Okay, so let's go to this one. 3 to the x plus 2. Now, what transformation do you notice here? I did say vertical, but what's happening vertically? Yeah, everything is shifting up 2. So you could go ahead and graph the original, just 3 to the x, and then just move every point up 2, or you could just plot the points as you go. Okay, anybody want to come on up and show me what this is going to look like? So many hands. I just need one. I don't have it pulled up, but I can get that random number generator real quick if you want. Eli was a big fan of that yesterday.
Yeah, but I broke too many furniture, so I only suggested.
Oh. Okay. Well, let's see here. Random number generator. Okay, so we had 12, 18, 20. Samir, you're in the 24th seat, right? Okay. All right. I think that's all we have here. So let me change this to 24. No volunteers? 11. That is Karime. And she looks very happy to have been chosen. Unless someone's willing to come up for you, the generator has spoken. Nobody's willing to jump on this landmine for Karime. Sydney! Man, Sydney's doing all. She brings us cupcakes, then she's going to help Karime out. Nice. Okay. Okay, here we go. So I understand, Karime, you were just wanting to do the next one, right? There we go. Yeah, I get how it is. She wanted something more challenging. Oh, I didn't even ask. Sydney, do you want the headphones? No? Okay. All right. She's like, nope, I'm good. Oh, I actually have my marker over here. Sorry. I don't know if you wanted to use red. I just accidentally took that with me. Okay, so 3 to the x plus 2, and then we want to figure out those characteristics. Okay.
Too far.
Okay. Now, where's the asymptote? There we go. So remember we said before that the only transformation that really is going to affect the asymptote is a vertical shift. So if everything goes up 2 and he was originally at 0, he wants to be at 2 as well. Okay, the domain is all reals. This is everything from 2 to infinity and beyond. Really? Nothing? You know they're coming out with that part 4 this year?
Oh, yeah.
Yeah? Should. Yeah. You didn't know they were coming out with part four? Yep. Okay.
It's so good. I think it's gonna be great.
What, Toy Story 4?
No, Will Smith as Aladdin.
I feel so bad. I don't understand why people are just hating it so much. You've only seen a couple of seconds. How can you judge something just that quickly?
I think it's gonna be so good.
Okay. Did you hear what one critic said? He said, I imagine after watching Bird Box, that's what people see that makes them kill themselves. Did you hear the guy say that? He said, after I watched Bird Box, I walked outside and expected to see cars crashing, but there wasn't. I was like, wow, are we really going to do that for a few seconds of digital footage?
I just thought it was a bad.
I don't know. I don't think it's bad. I like Will Smith. My question is, do we really need it? Do we need a live action version of every Disney movie? Doesn't Disney have a strong stranglehold on the world as it is right now? I mean, they own Star Wars now. They own Marvel. They own the Muppets. They've owned the Muppets for a while, yeah.
So now Mickey Mouse will be playing basketball with LeBron James.
Whoa, that's a little too far.
Okay, anyways. Sydney finished up for us. She says all reals, range 2 to infinity, y equals 2. Intercept for this graph, 0, 3. It is increasing. Okay, I would agree. Is there any questions? Anybody have anything they want to add to this particular problem? Okay. Well, now let's see. What else we got? So 3 times 1/2 to the x. And we did talk about earlier if there was a scale factor in front, that can immediately tell you something, so long as there was not a horizontal shift, and there isn't one here. So do I have a volunteer for this one? Karime? No? Okay. Are you sure? Because I stand up here and I'm wrong all the time, so don't let that worry you at all. It was really quiet when I said that. You guys are going to give me a little bit of encouragement. Like, no, no, no. It's too late now. I don't need your pity. Okay. All right. So let me go back over here. Okay. So no volunteers? 24. All right. So 3 times 1/2 to the x. Okay. Okay. Yeah. Everything's looking good except one thing.
So 1/2.
There you go. That's right. That's what I was talking about. 1.5. There you go. 0.75. Good. Okay. Okay, so there is no vertical shift, so the y asymptote remains, or should be the asymptote remains where it is. Bless you. There we go.
I'm sorry.
What's that, sir?
I did terrible infinity signs.
Oh, that's fine. They look great. Are you saying that bugs you?
Yeah, would it bug you?
You know, the one thing I'm really terrified about is like if Eli were asked years later, so Eli, what do you feel was the most important aspect of math studies you learned, you walked away with? You know, it's not you're not going to say anything mathematical. You're going to say I learned puns. 42. It's a dead joke in and of itself. Oh, a dad joke. Oh, okay. Right. We brought that up in here before, haven't we? 42? Yeah, okay. Okay, so let's see what Samir did. All reals for the domain, 0 to infinity. Asymptote y equals 0 to the x-axis. The intercept is 0. Is that a 2 or 3? 3, okay. No x-intercept, and it is decreasing because you have a decay base. It is less than 1 but greater than 0. Okay, good. Very good. All right. Well, let's say we go ahead and do one more, and then we will go ahead and call it quits for today. And then we'll just continue this on Monday. So negative 2 times 3 to the x. Okay. Now this one here has a transformation that we haven't seen yet. There is a vertical stretch, but what else is happening? It's going to be reflected. Now across what? The x or the y-axis? The x. Now, if the function itself is negative, it reflects with the x-axis. If x has the negative, then it reflects with the y. Okay? So, volunteers. $15. I believe that's Gabby. All right. Okay, going right to the table. Oh, no, I'm just like commentary right here. Okay, so she says if that's negative 2, negative 2/9 is correct, yes? Negative 2/3. Okay, then we have negative 2. Then she says negative 6 and negative 18. Would you folks agree?
Yes.
Okay, very good. Where's the asymptote? Is it in its original location or is it moving? It's original. Okay, there's no vertical shift here. Okay, good. All right, so what is our domain? Negative to positive infinity, okay. Yes. Remember, it always has to go from least to greatest. So what's smaller, 0 or negative infinity? There we go. So it's going to cap out at the asymptote this time. There we go. Negative infinity to 0. Asymptote y equals 0 x-axis. Zero, negative 2. No x-intercept. And this is still decreasing. Okay, very good. Actually, there's a couple things I want to bring up just very quickly. Is it possible to have a decay base but have it grow? Yes. Okay. Is it possible to have a growth base but to have it decay? Yes, and it deals with the reflections. Now, also one other thing. You remember? I think it was yesterday. It was sometime this week when we were talking about just given a table of data, being able to identify like the quadratic because we saw the symmetry in it. You should be able to see patterns here that would help you recognize if it's a quadratic or not. Okay. Like how do I go from a 12 to a 6? You take half of it, 6 to 3, 3 to 1.5. In fact, if you go through every one of the tables we've created today, the y values, you should see that base as a factor. Okay, just over and over and over again. Is everybody okay with that? Okay. Any questions? Okay. Well, then we will stop.